Hi, my name is Mike Rust, and today I want to talk to you a little bit about some implications from an ICES workshop on pathways to climate-aware advice. Specifically, this talk is about implications to aquaculture, although similar implications may be applicable to fisheries. First, I'll start with some conclusions, and basically that we use this method called Delphi, and it is an approach to rank climate impacts, adaptations, and mitigations based on expert opinion, and it has some distinct advantages, which are complementary to the more empirical science models and so on that ICES does in other areas, and could be appropriate for aquaculture advice. However, it's not as simple as it looks. So what is a Delphi? Basically, it's just a structured method for collecting expert opinions. It starts by identifying different options and formulating those options into questions that can be ranked. It then proceeds with a ranking exercise by a group of subject matter experts. Those experts do that as individuals, and then they're brought together for a discussion of those rankings as a group. And then after that discussion, they again re-rank those options as individuals. So it's important to note that this method does not come to consensus, but instead it provides an average opinion whereby each subject matter expert is a unit of observation. So the N in the end for doing statistics is equal to the number of experts doing the final ranking. So how we applied this to climate was first to think about what kind of approach we might want to have in the end. And we found from the economic forums that they often used this risk model where they ranked did a graphic with the likelihood and the magnitude of various risks to, in this case, the economy in this plot. So beginning with where we wanted to go, we then went back to IPCC and looked at the climate drivers that are out there, and then linked those through impacts to fisheries and aquaculture. Now, the traditional approach would be to look at risk, which is the negative, and hazards, but we discovered, or we understood, that there could be some opportunities as well. There are winners and there are losers. And so we created this mirror image to risk on the positive side that we termed opportunities. We then used the Delphi to look at the likelihood and the magnitude of these impacts flowing from the climate drivers to produce this plot. We then used the second Delphi to say, okay, what can we do about it? What is the opportunities first for mitigation? Mitigation is anything which reduces these climate drivers in the first place. Effectively, that means CO2 reduction. And then adaptation, and that is basically what can we do on the risk side to reduce that risk, reduce the likelihood or the severity of those impacts. And then on the opportunity side, what can we do to actually increase those? Although that concept was a little bit more difficult to get our heads around. And the pros to this method is we got some really cool results. We did get these plots of magnitude and likelihood, laying out a variety of impacts. The method was relatively quick and adaptable to remote work where you didn't need to be all in the same room. It was adaptable to diverse situations. We used both fisheries and aquaculture examples equally. It can be consistent, and it can be repeated over time. So this is an exercise where you would want to do it at some regular interval. And it also has the advantage that it's recognized by other sectors. So these plots are something that outside of ICES and outside of fisheries, outside of aquaculture, outside of marine sciences would be recognized. And there are some fairly cool plots that came out of this, and fairly cool things. We were able to tie together climate drivers, impacts to the industry, in this case aquaculture, and adaptation and mitigation approaches. And that allowed you then also to look at what adaptation and mitigation approaches actually had a fairly widespread ability to provide resilience to the industry and deal with various climate drivers. On the con side, for aquaculture especially, not so much for fisheries, there was a fairly low sample size. In other words, a low number of experts filling out the final ranking tool. I think in the end we only had 7 experts filling out the final tool, which drove those plots. And we also noted that we had an issue of diversity of expertise. For example, we had no economists, no social scientists. We had only one veterinarian, so there was issues of depth of expertise. We only had a couple people that had worked on seaweeds, a couple people on finfish, and so on and so forth. So those issues, I think that there are ways to get around those, but those definitely did call into question some of our connections and our results. And then there was some evidence of known bias with Delphi, and basically this is probably because this was new in our hands. It was the first time we did it, but I think there are suggestions on how to deal with those biases in the literature that could be applied. So going forward, the suggestion for ICES to move forward is to build expertise with the Delphi approach and use the risk opportunity model and use this as a TOR for a new working group on aquaculture and climate. And then use this group along with the existing aquaculture science steering group subject matter expert groups on diseases, genetics, ecosystems, social science, economics, so on and so forth, one group at a time to provide focused rankings for each sub-area of aquaculture, and then bring these together to do basically a ranking of the rankings to integrate the responses from many more subject matter experts, both diversity and in actual number. And in the end, develop standardized graphics and communication tools that the information can flow into advice products for, and then set up a repeating interval whereby this exercise would be repeated. Thank you.